This talk, for those of you that have been here in years past, we have changed it up completely. It's a 100% different talk than we've had in years past. As a result, it may be a little rough tonight because this is the first time I've given it, so hopefully it goes well, but if not, we're going to be working the bugs out on you. You guys are the guinea pigs. This is what we're going to go through in part one, and we have a lot to pack in before we get to a very brief break. We're going to start out with an introduction talking about why it is that we need storm spotters. You know, we can talk about the radar and the computers and everything we have at the office, but there is no substitute. We haven't come up with any way to substitute the human eye on those storms letting us know what's going on. You're going to learn that your reports fill in some very key gaps that we have in our system, and without them we could not issue good warnings. We're going to back up and talk a little bit real quickly, just review last year, some of the events we had, some of the storms that produced some damage. Some of them were right here in Johnson County. Then we're going to move on into the meteorology, and we're going to talk about some ingredients to thunderstorm development, different stages of a thunderstorm life cycle, and move on to 3 different types of thunderstorms. Those of you that have been here before will remember we're going to talk about single-cell storms, multi-cell storms, and the granddaddy of them all, supercell storms. Okay? We'll talk about the hazards that those storms produce, what you can expect from the different types of thunderstorms. And then before we go into our break, we're going to talk about some different cloud things that you can see, how you can identify different features on the clouds, what you should be looking for, and whether or not we want those cloud features reported into us. Okay, we're going to take about a 6-minute break in the middle there, and then we're going to get into situational awareness. And when I'm talking about situational awareness, what I'm really getting at there is how well do you know what to expect either later in the day or maybe even later in the week when it comes to severe weather. It's very important that you know what to anticipate as far as severe weather goes, so you know what to look for when you're out spotting those storms. We're then going to get into talking about some weather resources. You know, there's a lot of different places to get weather information today. Most of them are good. We're going to just highlight a few of them, some of them on the web, some of them maybe app-based or on your phone. We're going to then move into weather safety, kind of some of what Dan was talking about. And hopefully you can bring some of that safety information back to your friends, your neighbors, your family. And then we're going to finish up with what and how to report, what we want to hear from you about and how to report it in. And then we're just going to have a real quick outlook for what this severe weather season may bring, because we're coming out of a real strong El Nino year, right? That's why they're getting all the rain out in California. Well, there is some things that we can glean from the weather when we transition from El Nino to what they call El Nino neutral conditions like we are right now. And we'll talk about what that means for our severe weather season. So real quickly, just some housekeeping. Let's try to hold the questions since it's a big room till the end if we could. Now, if there's something that you've got to know about because it's going to completely screw up your learning process, okay, stop me and let's get it answered right then and there. But we've got a lot to pack in here, so we want to keep it going. As I mentioned, we're going to have a 6-minute break between the parts. And as always, when you're in a theater like this, mute your cell phones just so that they're not going off and ringing. Honestly, I don't remember if I muted mine, so if my wife calls, you'll hear and you can boo me or yell at me or something. All right, let's talk a little bit about our office. We'll start out talking about the National Weather Service, because I'm sure many of you have heard about the National Weather Service, and the National Weather Service has issued this, that, and the other thing. The National Weather Service is actually made up of 122 forecast offices scattered around the country. They're in every state in the union, as well as in some of our protectorates like Guam, Puerto Rico, and Micronesia. I guess we have offices there as well. But the most important thing I want you to know about our office, or about the National Weather Service, is we are really the sole providers for warnings in the United States. That's really our number one job that we have to do. We issue a lot of forecasts, we collect a lot of data, but really the warning issuance is really our number one priority. And that's why I'm so glad to see so many people here, because you guys will, as you'll learn, help us out quite a bit. Just specifically a little bit about our office. We're staffed with 23 professionals, 12 full-time meteorologists, 3 management positions that are also meteorologist positions. We've got several computer people and a few other support people. These are the 44 counties in far eastern Kansas, and then from west central through northwest and north central Missouri that we forecast and warn for. You've probably heard me in years past mention that we're staffed 24 hours a day, 7 days a week, with a minimum of 2 forecasters in the office. It's because the weather's always ongoing, and even though our forecasters do a great job of forecasting the weather, there are still some surprises. We got to have people on 24 hours a day. Now, you know that we issue forecasts and we issue warnings, but there's some other types of things you may not be aware of that we do. As far as the forecast goes, you know that we issue the forecast that says sunny, high of 70. You can get it on our website. You can get it a lot of different places. But we also do aviation forecasting. We forecast for, I don't remember which airport here in Johnson County, if it's Johnson County Executive or the other one. Anyway, we forecast what's called a terminal aerodrome forecast for them. We do it for the downtown airport in Kansas City, the international airport on the north side of the city, as well as the St. Joseph Airport up in St. Joseph. We have a variety of technical discussions that are meant to collaborate with our TV meteorologist partners, so we can kind of communicate the science of why we're forecasting what we're forecasting to help them better understand the situation. And then obviously the severe weather warnings. In the last couple of years, we've moved into an area called decision support. And we're really working to transition from just providing the data to now really worrying about how we communicate that data, specifically to our core partners like Dan and the rest of the folks at Johnson County Emergency Management. We want to make our forecasts as actionable as possible and to help them make decisions that will hopefully save people and property in Johnson County. So we're really working to make our information something that you can base important decisions on rather than just being very pure weather data. And then finally, we do a lot of data collection. We take observations. We have actually manage a network of about 100 what we call cooperative cooperative observers, I guess is what we call them. And those are folks that have a thermometer and a rain gauge at their house that we supplied, and many of these folks have been taking observations in the same location for 50, 60, even 70 years. That's these people are doing it every single day for 60 or 70 years. That's an incredibly important data set for us so that when we're looking at things like global warming and climate change, we've got to have a very consistent and accurate climate record so that we can evaluate the impacts of climate change on what that's going to do here in Kansas. So when we have that program, it's very important for us. But it also means that data is available if people are doing research, or let's say a factory is going to be built and they want to know about wind patterns or they want to know about climatology. They can go out and get all that data off the internet or go to the National Climatic Data Center and get all those records that we've been keeping for all those years. So it's there available for everyone to use. Now, I mentioned that we're staffed 24 hours a day with a minimum of 2 folks in the office. This would be a little bit more typical of what happens during severe weather. Now, this would be staffing for kind of a low-end severe weather event, but we have a lot more people in the office. We have a radar operator, of course. That is going to be the chief warning person, the guy that's making the decision on whether to warn or not warn on the storms. We've also got somebody that we call a storm forecaster. Now, that person's job is to feed information to the radar operator as to how the storm should evolve over the next hour or two. Try to help that warning forecaster kind of get the jump on those storms. Maybe they're not quite severe on radar yet, or we haven't gotten any reports from spotters yet. But that storm forecaster is going to be feeding information like, hey, this storm is moving into a more favorable environment. It could go tornadic in the next 30 minutes or so. So that's the kind of intelligence they'll pass back and forth. We also have a position that's called a communicator, and that's the person that communicates out with all the emergency managers, our media partners in TV and radio. They may go back and forth with the ham radio operators if they're in our office. A lot of things that communicator does. We also have a couple of statewide radio networks now that we're on for both Kansas and Missouri. We've got a person whose job is to deal with all or any flooding that may occur. That's usually our senior service hydrologist in our office. We've got just a forecaster, and that's the person who's doing all the forecast duties that we'd have to do on a quiet weather day. Well, just because we're in severe weather mode doesn't mean we don't have to do them, so we've got to have a person doing that. And then finally, the storm report specialist. That's the person you'll be speaking to if you call in to our office. They'll pick up the phone, they'll say National Weather Service, and you'll give them the report. We'll go through that towards the end of this talk. They also scrape social media looking for all the photos and all the things we've been tagged in on social media posts, whether it's Facebook or Twitter, for spotter reports as well. Now, as I mentioned, this is a low-end event to have 6 people in the office. If we have a pretty active event, like if you think back to May 2nd of 2008 when we had a couple of tornadoes move through the Northland, or you think back to May 4th of 2003, the last really big outbreak of tornadoes in the metro, we had, I believe they told me, 13 people in the office at that point. So we can really ramp up with a lot of people because the complexity of the event really demands a lot more as far as our staffing goes. Okay, let's talk about radar, because this is really where we get down into the nitty-gritty why it is that we need storm spotters. And now this is a bit of a simplistic image, but what I want you to understand is that radar, which we're kind of showing you over here with this little beam over here, that actually shoots a pulse of microwave energy out towards the horizon. But the FCC does not allow us to shoot that energy straight out at the horizon. They make us raise that antenna a half degree above the horizon. That means every little bit that energy gets away from the radar, we're looking higher and higher up in the atmosphere, and we can't see anything beneath it. In addition, the Earth is curved, right? That means the Earth actually falls away. So you can see as this beam goes out, it gets higher and higher up in the sky, and you can't see anything beneath it. So with storms close in, that's not really that big a deal, because we can see fairly low down to the ground. We still can't see what's going on at ground level. But we forecast and warn all the way up to the Iowa border, like Kirksville, Missouri. That's about 130 miles as the crow flies. At that range, we're looking about 15,000 feet up in the sky, and we can't see anything beneath it. It's very critical that we get spotter reports to let us know exactly what's going on the ground. Even close into the radar, we might estimate maybe we've got quarter size or ping pong ball sized hail falling, but until we get a report from a trained spotter, we don't know for sure. Your reports really help us correct for some of the insufficiencies that the radar has. Absolutely critical for us to issue good warnings. Okay, the other thing, in addition to helping us issue good warnings, your reports add credibility to the warnings that we issue. Okay, so when we take our scientific data there and we say a storm spotter cited this, the resulting warning is a lot more believable. I'm going to do a quick quiz here. I just want you to be thinking about this. If you hear a warning, let's say you hear it on TV, and the TV guy says, the National Weather Service issued a tornado warning for Johnson County. This is a Doppler radar indicated tornado, or this is a confirmed tornado cited by a storm spotter. Which one is more believable, or which one are you most likely to act on? Let's see a show of hands. Who's going to act more likely to act if it's a radar indicated tornado? Nobody? How about if it's a confirmed spotter, a spotter actually saw it? Yeah, of course we will. The radar is showing it that there might be a tornado there, means it might be happening. If a spotter sees it, it is happening. Okay? And so people pay attention to that. And so this is what it looks like in our warning. I mean, yeah, don't you love how the Weather Service or the government yells at you all the time? We always has capital letters. You would think that after all these years we could actually fix that. It's unbelievable how difficult a thing. This is not just like some guy forgot to turn his cap locks key off. This is hardwired in. But that's just the way it is. But you can see it looks just like this. At 6:52, a confirmed tornado was located near Lee Summit. This is actually from the warning that we issued for Jackson County last year for the Lee Summit tornado. Okay? So again, not only do your reports help us issue good warnings, they help the public believe our warnings. You add credibility to our warnings. Okay, in addition to your reports going to us, we fan those reports out to a variety of groups. If you send them to us, we will send them through a system called NWS Chat, which is a chat room that all of our TV partners are in, as well as all of our emergency managers and many other first responder type agencies. We'll put in there that so-and-so reported tennis ball size hail, near, we'll say 3 miles west of Overland Park. And then it goes out to all these agencies. They all get it at once. So you report it to us, a lot of different agencies get to see that information. And again, you're helping us provide a consistent message with all the agencies in that group. You're helping us convey that impact and sense of urgency. You're encouraging public action, and you're minimizing, in the end, loss of life and property. Okay? Very critical function that you guys do. Okay, real quickly, let's step back to last year. This is what happened back in 2015 when it comes to severe weather. Now, the map looks pretty busy here. There's a lot of different colored dots on here. I'm not going to go through all of these, but you can see the wind, the hail, the flood, and the tornadoes. There was no place in our forecast area immune to severe weather last year. It's a pretty good bet to say there's no place in our forecast area that will be immune to severe weather this year. That's why I'm so glad to see this room so full. But let's talk about some of the highlights. The strongest tornado we had last year was an EF2 tornado that was near Sibley. It actually did hit Sibley, Missouri, and went just to the west of Orick, Missouri. The largest hailstone that was reported was a little bit bigger than softball size at 4 1/4 inches. That occurred in DeKalb, Missouri. And the strongest non-tornadic wind we had was it was estimated to be 80 miles an hour as a bow echo swept through the Kansas City metropolitan area. We had that down in, or actually up in Riverside there. We had that 80-mile-an-hour wind. Just a few things we'll step through one at a time. Here's that tornado, that EF2 tornado. You can see the map of the track over here. If you're familiar with the area, it touched down just west of Buckner. Actually went through a garbage facility here. That stunk doing that part of the damage survey. Went right through Sibley. How many people have heard that tornadoes will not cross rivers? You may have heard that, but this one went right across the Missouri River. Didn't matter, like it wasn't even there. And then it ended up lifting just west of Orick, or northwest of Orick. One thing, I don't know if you can see this kind of like metal frame there? That's the undercarriage of a mobile home that was thrown against that tree and wrapped around it. So even though it was you say, well, it's only an EF2, that's still strong enough to lift a mobile home and throw it about 100 yards and wrap it around a tree. So pretty strong wind. Orick was kind of the epicenter or actually Mosby was the problem. That's right. I was thinking this was Orick. Mosby had some very significant flooding a couple of times last year. In fact, they had to evacuate the entire town at one point in May, and I think a couple of days later, they actually had another voluntary evacuation due to rapidly rising water. But we're no strangers to flash flooding here, obviously. That straight line wind event that we had in the Kansas City metro area uprooted trees throughout the city. There were many instances of trees falling on homes and falling on businesses and cars. I know of a gentleman who actually is very involved with our Skywarn program. His house was hit, or a tree fell on his house, and he just got back into his house last week. It took him 6 months to repair his house after that tree fell on it. So quite a bit of damage from, again, non-tornadic thunderstorm winds. Oops. Okay, where are we at? Okay, yeah, we had an EF0 tornado. These were actually we had two in Johnson County. One of them moved in from Douglas County. Did a pretty minor tree damage, but it did do some damage. And then it touched down again. The same storm produced another tornado about, I believe, 5 miles further to the east. Again, not a lot of damage. It was in mostly rural areas in Johnson County, southwest of most of the population center. This, to me, was the scariest of all the storms that we had in our forecast area. This was a series of two tornadoes that first touched down at Hillsdale Lake in Miami County before moving eastward into Cass County, Missouri. A couple of things that stand out about this storm: we did not have a warning out when the tornado first touched down in Miami County. We learned of that through a spotter report. It was actually a Miami County sheriff's deputy radioed in the tornado into our office. We knew the storm was strong. We didn't think it was tornadic. His report caused us to issue the tornado warning. That tornado warning was critical because you'll see here this high school football field here. This is the Cass Midway High School football stadium. We issued that warning. This is a Friday evening. We issued that warning at 6:40 p.m. that night. People were in the stands and the teams were warming up on the field when we issued that warning. School officials heard the warning and they got everybody inside into the high school, which is behind here, and the tornado struck at 7:03, 3 minutes after what was supposed to be kickoff. Had it not been for the spotter report from that sheriff's deputy, there's a chance we wouldn't have got the warning out and people would have been in the stands when this tornado moved through. Probably would have had some fatalities, certainly some injuries. Okay, so that's pretty scary near miss, I guess. Okay, let's move on to the meteorology. Let's talk about the ingredients for thunderstorm development. We've used some different words to describe the ingredients this year. The first one we're going to talk about is humidity. How much moisture is available in the atmosphere for thunderstorms to develop? If you've been here in years past, you've heard me describe humidity or the moisture level as the fuel for that thunderstorm. You've got to have moisture because that's what's going to fuel that thunderstorm to develop. Okay? Another factor we look for is how much energy is available in the atmosphere. And that's really kind of an explosive energy force. We think of that energy kind of like as the thunderstorms are forming, and you've seen time lapse where storms are just building very rapidly. That's really almost like an explosion occurring. Okay? The more energy that's available, the more explosive that thunderstorm growth is going to be. We oftentimes need fronts in the low levels of the atmosphere to give us a little bit of a nudge upwards to break whatever cap may be left over. We'll talk about the cap in a slide or two. But those fronts tend to trigger thunderstorms. That's kind of the little thing that will get the storms to initiate and start to grow rapidly. And then finally, if we're going to have severe storms, we've got to have wind shear. Wind shear is going to take what might be a pretty meager storm otherwise and turn it into a beast. Okay, now all wind shear really is the change in either speed or direction with the wind as you go up in the atmosphere. Sometimes it's both. Speed and direction will change as you go up in the atmosphere. The stronger the wind shear, oftentimes the stronger the storms you end up getting. Okay, so those four ingredients are really going to control what type of storms we get and how severe they are. Okay, and I mentioned that cap before. Now you might say this is kind of a goofy picture, right? Kind of a cartoony thing, but it kind of proves or kind of describes a point here. A cap is a layer of warm air in the mid-levels of the atmosphere. We can have all four ingredients that we talked about on the previous slide, but if we have a cap in place, that's going to inhibit thunderstorm growth. Now the storms will fire though if we've got an area where the cap is weak or an area where the cap doesn't exist at all. So that's one of the things we'll be looking at in the office, trying to identify, is a cap in place, and are those four ingredients we talked about on the last slide going to be strong enough to either break through that cap or work their way to the edge of the cap to allow the storms to develop. Okay, we're going to talk about 3 stages of thunderstorm development and kind of we'll describe what it looks like when you're actually seeing it out there. We'll start with the developing stage. In this stage, the storm is all updraft. In fact, it doesn't look like much more than a kind of a large cumulus cloud. When I say it's all updraft, I mean all the air inside that cloud is moving upwards. We probably don't have any rain yet. Certainly we don't have any severe weather. The thing's just getting its act together and starting to produce the raindrops. This is what it would look like if you're looking at that. Again, doesn't look like much more than just your everyday garden variety cumulus cloud, puffy cotton ball cloud, except it probably is growing vertically a little bit more than the typical fair weather cumulus cloud. As that cumulus cloud continues to grow, it moves on to the mature stage. Now, once we reach the mature stage, the updraft has developed enough that it's producing precipitation. As that precipitation falls, it produces a downdraft. So as the precipitation falls, it's dragging the air down with it. That gives us the downdraft. That's where all the rain is falling. All the rain falls in the downdraft. As that downdraft air hits the ground, it spreads out, and that's what can produce our strong straight line winds. During the mature stage of thunderstorm development, that's when we're most likely to have severe weather. Whether it's large hail, strong damaging straight line winds, flooding, or tornadoes, it's probably going to be during this mature stage thunderstorm. Now before we do that, let's take a real quick look. Essentially, basically just our thunderstorm is what it looks like, right? We've got strong updraft here. You can kind of notice how there's like a very crisp, hard edge to the cloud there on that. That's all updraft. That tells me that's all updraft. Over here is where all the rain is falling in the downdraft. It just looks kind of more washed out a little bit there. Okay? Once that downdraft completely takes over the updraft, it cuts off that moisture supply, that fuel that's moving into that thunderstorm. And when the thunderstorm's all downdraft, it's pretty much on its last legs and it's dying. Generally, all the severe weather has ended at this point. The only type of severe weather you may get in this stage of thunderstorm development is the possibility, and it's a bit of a rare possibility, of strong straight line winds from something called a microburst. Otherwise, it's pretty much on its way out. Okay, and this would be an example of what you might be seeing if you're looking at a dissipating thunderstorm. Again, you still got some of the anvils up on top, but otherwise it just looks like it's raining itself out there. Okay, so developing, mature, and dissipating stages are the 3 stages of the thunderstorm process. Okay, we're going to go through each of the thunderstorm hazards now one at a time. You want to hit the video or turn the video sound on? A lot of different types of thunderstorms can produce strong straight line winds like that. Most of the time when we get straight line winds in the thunderstorm, we're only having winds of 40 or 50 miles an hour, but our stronger storms can produce winds 80, maybe approaching 100 miles an hour. That'll do damage like we saw in Kansas City last year, where we had uprooted trees snapped off. It can destroy mobile homes. It can rip the roof off of houses. Straight line winds are nothing to mess with, can do quite a bit of damage. Move on to the next hazard, that's hail. Got another video for that.
Hey, that did it. That hit you. Because it's going to hit him in the head and probably hurt him if he gets hit. Hey, there's a deer. Oh, yeah.
Okay, so number one, don't go out and pick up the hail while it's still falling. Don't walk through it like that guy. He was pretty calm about it, wasn't he? Kind of nuts, if you ask me. Let's talk real quickly about how hail forms. As you go up in the atmosphere cools off, and generally during our severe weather season, the air temperature falls below freezing somewhere between 12 and 15,000 feet above the ground. Thunderstorms themselves can grow to be 50 or 60,000 feet high. So what we end up with the updraft producing the rain. The rain ends up getting thrown above the freezing level. It freezes, and then for one reason or another, it may cycle back down below the freezing level again and acquire more rain on it. So now you have a little hailstone that's wet. It gets lofted back up above the freezing level, freezes, falls back down again, gets thrown back up, freezes again. So you just keep adding layer and layer and layer onto those hailstones, and they grow bigger and bigger until eventually they grow big enough that they will fall out in the downdraft or kind of on the margins of the updraft. Okay. We mentioned before that the largest hailstone in our forecast area that was found last year was about 4¼ inches. This one measures about 4½ inches, so that's about how big the biggest hailstone we found last year was. Very large, but obviously can do a lot of damage. One of the things I didn't mention, one of the things that the National Weather Service is charged with is we are charged with protecting life and property through the issuance of our warnings, right? We're also charged with enhancing the national economy. You might say, well, how in the world is the National Weather Service going to enhance the national economy? Well, if you guys, let's say it's a bright, sunny Saturday afternoon, maybe you had the car out in the driveway and you washed it or whatever, and now thunderstorms are moving in, and we issue a severe thunderstorm warning and say there's baseball-sized hail headed to Johnson County. What are you going to do with your car? Pull it in the garage if you can, right? If we can save the money of not having to repair your car, that's an enhancement in the economy, right? If we do that across the entire country, that adds up to billions of dollars a year of losses that didn't happen. So that's just one example of how we can do that. Okay, let's move on to the next video. You guys don't even have to turn the sound on for this video. It's pretty quiet anyway. We're going to talk about flash flooding.
Mas o ônibus ficou preso e todo mundo teve que descer. Em seguida, a pista desmoronou e o ônibus foi levado pela correnteza que passava embaixo da estrada. Olha aí. O DENIT informou que isolou a área.
Okay, we've got a slogan at the National Weather Service that we do use as a safety message called "Turn around, don't drown." Essentially, if you approach a flooded roadway, don't drive through it. But also, even let's say there's just a torrent of water raging through a culvert underneath the road. You don't even know what the status of that culvert is. Is it still there, or in that video, as we saw, has it been washed away, and now your vehicle may fall through the road and get swept downstream? Okay. Obviously, we know that flooding is caused by locally heavy rainfall. Anytime we get 3 to 5 inches of rain in like less than 3 hours, we're going to get flooding. But when the soils are already wet, we can get flooding with as little as an inch of rain in an hour if we've already got saturated soils. It doesn't have to be a huge downpour. So the main thing I want you to take away from that is the safety rule: turn around, don't drown. Absolutely never try to drive through floodwaters. All right, let's look at a tornado video. That's probably why most of you are here anyway. cow. I need that kind of sound system at home. That's pretty good. That's really good. Okay, now if I asked you what a tornado was, you're probably not going to come up with this definition, but that's a pretty good definition. It's a violently rotating column of air extending from a thunderstorm in contact with the ground. Now, it doesn't say a violently rotating cloud, does it? It says column of air. This condensation funnel that we oftentimes see in tornadoes does not have to reach the ground for it to be a tornado. Maybe it looks like a little funnel cloud and that's not touching the ground, but you may notice dirt swirling at the surface or debris. That's a tornado. Okay? The cloud itself doesn't have to reach the ground so long as that circulating column of air reaches the ground. That's what makes it a tornado. Okay? Now, one of my jobs, after we've had a tornado that hits something, I go out the next day, or if it's early enough in the day, I go out that day, and I will look at the debris, see what the storm hit, and we've got some software, some computer programs that help us estimate wind speed based on the type of damage that was produced. That kit is called the EF kit, or the Enhanced Fujita Scale kit, and we essentially use the EF scale. And it ranges anywhere from EF0 to EF1, which are our weakest tornadoes, with winds generally less than 110 miles an hour. That's the vast majority of all the tornadoes we get around here. That's about 5 out of every 6 tornadoes is an EF0 or EF1. Then we move up to the EF2s and EF3s. That's when we really start to do some damage. If you look at this photo over here on the right, that's when you start to rip roofs off of houses. Mobile homes are completely demolished. You may lose some exterior walls to homes and other well-built structures. And then when you move down to EF4s and EF5s, approximately 1% of all tornadoes ever make it to be that strong a tornado. With an EF4 or EF5, you're talking about foundation swept completely clean. The home is completely gone. Okay? In fact, a lot of times if you pay close attention after a very devastating tornado like we saw down in Joplin in 2011 or in Greensburg, Kansas several years ago, the National Weather Service, when they first come out with their tornado rating, they'll say it was at least an EF4. Do you know why they say at least an EF4? It's because a house will be swept away with an EF4. We've got to look for something else to determine if we actually have an EF5. Okay, so they have to look for stronger built structures to determine whether or not it was an EF5. Okay, so that's why they'll say at least an EF4. Now, even though that's only about 1% of all tornadoes, that's where most of our fatalities in tornadoes occur. Now, we probably won't talk about this when we get to the tornado section, but one thing I want you to understand, even if you live in a house that doesn't have a basement, if you have an EF4 or an EF5 coming towards you, you still have a pretty good, I want to say about a 90 or 95% chance of survival just by going into the lowest level interior room in that structure, like a bathroom or a closet, even if it's an EF4 or EF5 coming at you. Okay, finally let's talk about lightning. I'm going to back that up again. When you turn the sound on, I'm going to back that up and play it again because it's pretty good. Yeah, I heard this guy say I think he's got some electrical problems now in that car. Maybe. I'm not going to get too far into how lightning forms other than to say it's caused by ice particles in the thunderstorms, and as they bump into each other and then get separated by the updrafts, we end up with a charge separation between some portion of the cloud and the ground. Once that charge separation grows to be strong enough, you'll get that lightning bolt that will actually transfer the electrons from one location to another. That's what gives you the lightning. Now, we do not issue any kind of warning for lightning. You can have an incredibly vibrant lightning display, and we won't issue a warning for it because that's not what we define. Even though lightning will kill you and is hazardous, every thunderstorm has lightning, so we don't issue warnings for it. Okay, it should we call it self-alerting because if you hear thunder, right, you know there's lightning associated with it. Okay, now let's move on to those 3 types of thunderstorms that we're going to talk about that we talk about every year. You've heard me say this before that there isn't just 3 types of thunderstorms. There's an actual entire spectrum of thunderstorm types out there. But these are just the 3 types we're going to cherry pick and talk about. Now, they range anywhere from the single cell storm or pulse thunderstorm or garden variety thunderstorm over there on the left-hand side that are almost never severe, all the way over to the supercell side of the spectrum, the granddaddy of all thunderstorms that are almost always severe. Okay, so keep that in mind. Now, the thing our forecasters look at to determine whether or not where on that spectrum we're going to fall on any given day is they will look at how much energy is available in the atmosphere, how much instability is there, as well as how much wind shear is there. And if you have a very weak wind shear and very little energy available, you'll be over here on this side of the spectrum. If you've got a lot of those two ingredients, you'll be over on this side of the spectrum. Okay, let's start out talking about the single cell thunderstorm. Remember, with the single cell thunderstorm, there's not a lot of energy available, not a lot of shear. As a result, the storm tends to go directly straight up and down. Okay, and you'll notice over here, as far as severe weather risks, kind of a low risk for severe wind, low risk for severe hail, maybe a moderate risk for heavy rainfall, and almost no risk for tornadoes. Okay? Generally, if you read any of the Outlook products that we're going to talk about later in this talk, and you hear single cell thunderstorms or pulse thunderstorms or something like that, probably not going to be a severe weather day. As we get a little bit more shear and energy, real quickly, that's what it might look like, just a kind of a garden variety thunderstorm just with some rain. Not much going on. Now, as I was saying, as we get a little bit more shear and instability in the atmosphere, the storms tend to organize a little bit better. That moves us on to the multi-cell cluster thunderstorm. And with this storm, what we're really dealing with here is we've got several different single cell storms kind of all mashed together into one complex. So maybe while this whole complex of storms isn't moving, these individual storm cells are actually moving in from the left and intensifying until they reach the mature stage and then moving off to the right as they dissipate. Now, you may have a little bit higher chance for severe wind and severe hail with this type of storm. The biggest risk from this type of storm is probably going to be flash flooding from localized heavy rain if all these storms intensify and dump their rain over the same locations. Now, this isn't that big a deal, the multi-cell storm. The type of storm we're really concerned about that we'll talk about in a couple of slides is the squall line. But let's take a look at what this may look like, a multi-cell cluster storm in real life. So we're looking at this. We've got towering cumulus, or the developing stage of thunderstorms. We've got the mature stage thunderstorms here. And then we've got maybe dissipating stage thunderstorms over there where the storms are weakening. Okay, let's move on to the squall line. All a squall line really is a long line of connected thunderstorms. Oftentimes they form along cold fronts. These things can range in length from maybe 1,000 miles in length down to maybe 20 or 30 miles in length, depending on how big the system is. And this is kind of a cross-section through a squall line. What we end up with is inflow into the storm there, and then the rain is formed, and notice the rain falls over here in the downdraft. When this downdraft hits the ground, again, the air spreads out in all directions. You tend to have the most intense straight line winds in the direction the storm is moving. So on the leading edge of the storm, there's going to be a feature called a shelf cloud that we're going to see. This isn't that good a look of a shelf cloud in this diagram. We'll see better pictures of that. But you're most likely going to see strong straight line winds. And if you look over here at our little, we call it a risk meter, or what I guess we could call it a risk meter. Look at the highest risk from this type of storm is from strong straight line winds, maybe a little bit better hail risk, kind of a so-so heavy rain risk, and a non-zero tornado risk. Actually, with squall lines, we can have a fairly decent shot of getting some tornadoes. But really, the thing we're most concerned about with this type of storm is damaging straight line winds. Now, this is what it may look like on radar. You'll see the squall line kind of develop right in there. This is the squall line that moved through the metro and uprooted a bunch of trees last summer. Okay, that's what it'll look like to us at the Weather Service. And here's what it may look like to you when you're out looking at these things. You'll notice here's the shelf cloud here. The whole storm system is actually moving from left to right. Ahead of this shelf cloud, the wind is probably blowing into the storm like that. That's the updraft. The downdraft forms over here, and you notice underneath this shelf cloud, see all this dirt getting kicked up by the strong straight line winds? What you will experience when you're out there is when this shelf cloud gets about immediately overhead, the wind may momentarily go calm, and then all of a sudden you'll get hit by a big blast of strong straight line winds coming out of that storm. Okay, so be thinking about that, anticipating that. When the shelf cloud moves through or you identify a shelf cloud, you should be thinking strong straight line winds. Let's take a look at a few more shelf clouds here. Here's another example. Again, this is kind of moving at us, coming out of the screen. Again, there's the shelf cloud right there. The winds would be blowing out of the screen like that. Here's another example of a shelf cloud that's moving at us. Maybe it's still 20, 30 miles away or so. All right, any questions about the squall line before we move on? Okay, we're going to move on to the supercell thunderstorm. And as you've probably already seen over here on the risk meter here, it's pretty much high risk for everything. Every severe weather possibility we have is pretty much pegged out on a supercell. As I mentioned earlier, almost every single supercell is severe at some point in its life cycle. If you got baseball or softball size hail, I promise you it probably came from a supercell thunderstorm. All right? Most tornadoes are produced by supercell thunderstorms. They can produce straight line winds of 80 to 90 miles an hour, and oftentimes they produce flash flooding. Okay? Now the good news for us, climatologically speaking, on average, we only have 3 or 4 days a year that all the conditions come together for us to have a pretty decent shot at supercell thunderstorms. So even though they produce most of the damage, they occur on a very few, or just a handful of days. Now this is what a supercell may look like to us. By the way, we're going to get into this diagram a lot more in a little bit. But this is what it'll look like to us on radar. This is a very classic supercell signature. Some of you are probably familiar with the hook echo. That is this kind of curlicue shape right down here. The reason that hook echo forms, by the way, all the rain and the hail falls in the downdraft, so that's all downdraft. The updraft is right here. The definition of a supercell thunderstorm is a storm with a persistent rotating updraft. So if the updraft is rotating like this, kind of like that, it pulls some of the rain around the backside of the updraft and kind of wraps it up like that. That's how you end up with that hook shape. You can look at this supercell image and see that hook echo and say, oh, that thing's rotating. It's probably cranking pretty good. All right, because we have that nice hook echo there. Here's what it may look like to you. Now this is the updraft for that supercell. Notice how it looks kind of circular shape. We call that a mesocyclone. It is rotating. You will not see it rotating with the naked eye because that thing's probably 5, 6, maybe 10 miles in diameter. That's not going to be cranking around like that, something 10 miles in diameter. Not happening, right? Remember, in a supercell thunderstorm, the rain falls in the downdraft. So while this is the base of the updraft, it's a rain-free base. The rain you see in the background is actually where the downdraft is, all the way over there. That's downdraft. The air is flowing up into the thunderstorm this way, and it's rotating. This whole updraft is rotating like that. At the base of this mesocyclone is where you want to watch for possible wall cloud development. We'll talk about that after a few more slides, but let's look at a few more examples of supercell thunderstorms. Here's another example. You can see this kind of the mesocyclone there. Probably wall cloud there. So another example, there's the updraft of the mesocyclone there. All this rain is falling over there. Another example of the mesocyclone, the rotating updraft there. And another, here's the time lapse we're going to show you. There you can actually see this is what you will not see with the naked eye, but you can see that thing rotating with this time lapse image. Okay. All right. Quick question before we talk more about supercells. Which storm type is most likely to produce significant golf ball or larger size hail? Is it A, a squall line, B, a multi-cell cluster, C, a supercell? Who thinks it's A? B? C? Okay, you're all paying attention. Good. That's a gimme. Good job. Okay, so we've got this schematic of the supercell thunderstorm. We want to talk about the wall cloud because that's really where the tornado is most likely to drop out of. Remember I said that rain-free base underneath the updraft, we call this whole thing here, the mesocyclone. You're watching this mesocyclone for a while, even though you can't see it rotate because you know that if this thing's a supercell, there's a possibility it's going to drop a wall cloud. You're watching for that. When you see that isolated lowering drop out of that rain-free base, if it is rotating, it is a wall cloud. If not, it's just a low-hanging cloud. It would be something like this. Okay, that wall cloud may be a mile, mile and a half in diameter. Something that big isn't going to be cranking around that fast. The kind of rotation you will see is stuff very slowly in the foreground going like that, and stuff in the background kind of going like this. That's the kind of rotation you'll see. And I've got a video here we're going to show you in the next slide that you'll see that kind of very slow, what appears to be slow rotation. But again, remember, if that thing's 1.5 miles in diameter, those winds are probably going 80, 90 miles an hour in that wall cloud. But anyway, you want to pay attention to that because if a tornado develops, that's where it's going to develop from. So let's take a look at this wall cloud here. I want you to see this is real time, not time-lapsed. And you see this stuff kind of going like that in the foreground, and in the background it's kind of going like that. That's the kind of rotation you'll see in a wall cloud. Okay, let's take a look at, I think, at least one more wall cloud in here. So here's the mesocyclone, right? The updraft. That would be the wall cloud there that's rotating. Obviously it's a photo, so you can't see it rotating, but you get the idea. Oh, yeah, one other point we need to make here. Now, if you're looking at a tornado or a funnel cloud, we want those reports called into our office. We're going to go through the various things you can do to send reports into our office. It kind of cut off on the screen here, but we were showing you our Twitter account, our Facebook account. If you are out in the field and you see a wall cloud, we would love for you to take a photo of it, a video of it, and send it directly to our office. Picture's worth 1,000 words, and it would help us out quite a bit. So just keep that in mind. Pull out your phone, take a quick shot, and send it to us. Okay, we're going to go through a couple of different cloud photos here, and we're going to try to decide whether or not we want those reported in. Now, certainly, as you can see over there on the left-hand side, we want tornadoes, funnel clouds, and wall clouds reported into our office. Those are good things to report in. Other things, though, shelf clouds probably don't need to have that reported in, and certainly we don't want scud clouds or SLCs reported in. What's an SLC? That's right, scary looking cloud. That's all it is. You don't need to report that into us. When you're trying to identify what you're looking at there with the cloud types, you need to ask yourself 3 things. First of all, what I'm looking here, does this make sense for the type of storm we're expecting, the type of storm we're looking at here? Maybe you're expecting just ordinary thunderstorms and you think you've got a tornado. Geez, that's probably not, if that is just a general thunderstorm, not a supercell, it's probably not a tornado, so does it make sense? I'm not so sure it does. Is it rotating? Is the cloud feature you're looking at rotating? If it's not rotating, it's not a funnel cloud, it's not a wall cloud, it's not a tornado. It's just something else. And finally, is it touching the ground, or do you see debris, or is there circulation occurring at the ground? Those are 3 good things to ask yourself if you're trying to determine whether or not you have a funnel cloud or tornado. Okay, let's talk about scud clouds. These are like little fragmenty kind of clouds that can hang below the cloud base. Sometimes they can actually touch the ground. They can occur underneath of wall clouds, which really confuses the issue. But again, with these scud clouds, you need to be checking to see, is it rotating? Okay? So let's take I got a time-lapse video here, I think, coming up. Yeah, let's watch. That's pretty typical of what scud clouds may look like. It may freak you out if you're in a tornado watch or a tornado warning, but if this thing is not rotating, it's nothing more than a scary looking cloud. So when we're looking at that type of cloud, is it part of a supercell? Well, no, probably not in this case. Is it cohesive and rotating? Is the whole thing rotating together? Or are these just some cloud filaments that are rising up there? Yeah, probably not rotating. And is there a debris cloud, or is it touching the surface? Well, maybe, but it's not a tornado, is it? We don't have any rotation, and it's really not part of a supercell, at least in this case. Let's look at some other clouds. Here's some more lookalikes here. That's pretty darn scary. And in this case, this actually was part of a supercell. I'm getting more worried. Okay, so yes, this one was part of a supercell. This feature we're looking at here and over here. Was it cohesive and rotating? In this case, it actually was not rotating, even though it was touching the ground. This was not a tornado. It's critical that you make sure you have all those things to determine whether or not you have a tornado. And really, the biggest thing in something like this to look at is to look for that rotation, right? Because, I mean, if you're driving down the road and you see that, are you going to be freaked out? I would be. I'd be like, holy cow, that's a tornado. But you've really got to focus in and see if you've got rotation. Is there debris down there? And what am I dealing with here? This is just kind of like a scud cloud on steroids there. How about here? Is it part of a supercell? In this case, it actually was part of a supercell. We're talking about this feature right here. Yes, it was. Is it cohesive and rotating? Yes, it actually was. Is there a debris cloud or touching the surface? I don't know. You can't really see it, can you? Certainly, we've got a funnel cloud at a minimum, and maybe a tornado, depending on what's going on the other side of the trees there. How about this? Is this part of a supercell? It actually was. Was it cohesive and rotating? Yes, it was. Has it got a debris cloud at the surface? I don't know. I can't tell. Okay, so I'm not sure if we got a tornado. Hopefully, you're not spending too much time trying to figure out if you got a tornado. Just call us, man. Let us know. Hey, I got a funnel cloud here, because something like this can touch the ground in a matter of seconds. Okay, this one's pretty easy, isn't it? Part of a supercell, yes. Cohesive and rotating, yes. Debris cloud at the surface, yes. Tornado. Okay, real quick, got a survey question here. What are we looking at? Is this a wall cloud? Is it a shelf cloud? Is it a scud cloud, or is it a tornado? Who says A? Who says B? Who says C? Who says D? You guys are pretty good. You're sharp. All right, good job. Okay, let's take a look at some of these other photos, though, because not all storms are clear-cut. In fact, we've got several people in our office that are storm chasers. They do that on their off time, kind of as a hobby. And I've had other friends in the past that have been storm chasers. Even the most experienced storm chasers have told me that sometimes they've been out in the field watching these things, and they're not entirely sure what they're looking at. Okay, even though they've got a radar display in front of them, they're looking at the storm, it's not always clear cut. So what are some of the things we're looking at here? What would you ask yourself if you were looking at this feature right here? Is it rotating? Also, does it make sense that a tornado would be there, right? Is this a supercell storm or is it a single cell storm? You know, does that make sense? Is it touching the ground? Is there debris? I don't really see anything. How about here? Same sort of thing, right? It's kind of hard to tell what you're looking at there because the rain is masking it a little bit. Finally, here's another example. We've got to actually have a tornado here. Here's the funnel cloud, and there's a little bit of debris. So you really got to kind of pay attention to the details there. We're going to get into something called situational awareness. And when I talk about situational awareness, as I mentioned before, it's really how well do you know what to expect later in the day. So I've got a short video I want to play just to kind of give you an idea of how, if you don't know what to look for, there's a good chance you're going to miss it.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away.
Sorry, madam.
It's just a matter of observation. The real question is, how observant were you?
Action.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Well, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
Okay. Okay, it said it's easy to miss things you're not looking for. The same thing is true when it comes to spotting in severe weather. If you don't know that it's a supercell day and you should be looking for wall clouds and possible tornadoes, you may miss it. If you don't know that we're expecting a squall line moving through, you may not know to be looking for the shelf cloud and anticipating strong straight line winds. If you don't know that it's just a garden variety, ordinary kind of thunderstorm day, you may be thinking you're seeing some things that really aren't there, and in fact it's just scud clouds or SLCs. It's very important for you to be able to anticipate what you should be seeing, and that's where we get into the situational awareness aspect here. We're going to go through several different ways you can build your situational awareness through a variety of different things that our office produces. We're going to start out talking about outlooks, things that occur maybe 1 to 3 days in advance. Okay? 1 to 3 days in advance, we produce a variety of different graphics. We send those things out in both Facebook and Twitter. Who here has a Facebook account? How many of you follow us on Facebook? I would hope you do. Our forecasts are doing a fantastic job of sending stuff out. These little business card things that were out there, they'll still be out there afterwards. They have our little Facebook address on there. Pick one up and follow us when you get home. We send a variety of all sorts of Outlook type information via both Twitter and Facebook. Okay, who has Twitter in here? Are you following us? Good. I'm glad most of you are. We also produce something called the Situation Report down here. This is on our website. You can get to our website by going to weather.gov/KC. That address is also on this little business card that was out front. You click on this little graphic down here and it shows you, it'll take you to the Situation Report. This is a Adobe PDF graphic. It's anywhere from 1 to as much as 4 pages depending on how complex the weather situation is. And in this thing, we pretty much pull all the relevant information and graphics you need from across the web and stick it into one document so you can just look at this thing and build your situational awareness on any given day. Okay, it's a very easy thing to look at. Oftentimes it's going to, it's just going to be one page. It'll take you 30 seconds to figure out nothing's going on. Other times you might want to spend 4 or 5 minutes and do a better job of reading this to get a better idea of what's going on. Okay? One of the things you will see oftentimes in this situation report are these colored graphics that show severe thunderstorm risk for various days. Those are produced by the Storm Prediction Center, and the colors on there range anywhere from just general thunderstorms on up to a high probability of severe weather. These days over here with a high probability, those are the kinds of days like we saw with Moore, Oklahoma, the huge super outbreak of tornadoes back in 2011 down in the deep south. I'm trying to think, this will be 9 years that I've been in Kansas City. I think we've had one high-risk day since I've been here, and that didn't even pan out for us. So, they're very, very rare events. But when we are in a moderate or even a high risk, something bad's likely to happen. Okay? It's just very few of those are issued anywhere in the country every year. And just here's an example of what you're looking at with the severe weather risk, by the colors. We do as good a job as we can to label it, slight, enhanced, or moderate. And we usually have a color-coded key down there to help describe that. If you're really into it and want to see probabilities of certain types of severe weather happening, you can go to the Storm Prediction Center website. Sometimes we include those graphics on our website as well, along with an explanation. But that's all part of that situation report that I showed you how to get to from our website. So, real quickly, quiz question. How can you build your situational awareness? A, through social media, B, local television, C, reading the situation report, or D, all of the above. Who says A? Who says B? C? D? That's right. All of them would be an acceptable answer. The local TV folks do a great job of explaining the weather scenario. So just because it maybe didn't come directly from us doesn't mean it's not a good source of information. Okay, let's move on down through this funnel a little bit more. The time frame is getting a little bit closer. The event is nearer in the future. That's when we kind of get into the watch phase. And all a watch really is it's a pretty large area, and it's almost like a forecast. And we're telling you that For instance, in this big blue area, that's a severe thunderstorm watch. We are telling you that atmospheric conditions are there that if storms should develop, they may become severe in or near this watch area. Generally, these watches are issued anywhere from 2 or 3 to 7 or 8 hours in advance. When we issue this watch, it does not mean it's time to seek shelter. It just means you need to have a heightened sense of awareness, because if storms form in there, they may become severe and cause us to issue warnings. We've got a variety of different watches we issue. We have severe thunderstorm watches, tornado watches, and flash flood watches. Real quick question. Can you get a severe thunderstorm in a warning in a tornado watch? Yes. Can you get a tornado warning in a severe thunderstorm watch? Yes, that's right. When we're issuing these watches, we're trying to issue the type of watch which is the most likely type of warning we're going to be issuing. Following it up with, okay? You can get these watches. Oh, wait. Oh, okay. Got another question. Forgot about this. Which best fits a tornado watch scenario? Should a tornado watch be issued when you have existing storms that are pulsing up and a few are starting to show broad rotation? Or B, storms are expected to develop soon and the atmosphere supports tornadoes? Or C, tornadoes are imminent or ongoing? Who thinks A? How about B? How about C? Okay, actually, the answer is B, because we try to get these watches out ahead of time before the storms ever develop. And in this case, the atmosphere is supportive of tornadoes. We just maybe don't have the storms yet. So again, we're giving you a little bit of a heads up that those storms may be coming. Okay, you can get watch information through both Facebook and Twitter. We also have a variety of other type of kind of short-term updates where we try to highlight what's going to happen as the thunderstorms evolve. Both of those we'll send out on either Facebook or Twitter, or usually both. Okay, so again, good information to follow from our forecasters in the office. Let's move on further down the funnel and talk about the warnings. When we're talking about warnings, we're talking about information that's given to you just a matter of minutes before the storm actually strikes you. Okay, we're really getting down to the nitty-gritty. It's go time. If that warning is issued and you're in it, you better seek shelter. Okay, the types of warnings we issue, again, oops, I guess I'm supposed to read it down here. Severe thunderstorm, tornado, and flash flood. Okay, makes sense. Now, the warning means that severe weather is either imminent or it's already occurring, and again, this is when it's time to seek shelter. Okay, you can get warnings. Most of our warnings you can get from Twitter. It's very rare that we put a warning in Facebook because we don't want to clog up people's Facebook news feeds. Twitter just seems a little bit more forgiving as far as very rapid posts. But I will say it's not an official warning communication portal for us. So we may not get every single warning on Twitter, but we're going to do our best. Okay, and these are the types of warnings we issued. We already talked about that. Oh, one thing I didn't mention though, and I will mention, we define a severe thunderstorm as a storm possessing either 1-inch diameter hail or larger, or 58 mile-an-hour winds or greater. Those are the two things we issue severe thunderstorm warnings for, nothing else. Okay, so keep that in mind. So a bunch of lightning, not a severe thunderstorm. Dime-size hail, not a severe thunderstorm. 50 mile-an-hour winds, not a severe thunderstorm. It's got to meet that criteria before we're going to issue a warning for that. Okay. Another question similar to the watch question, which of these fits a tornado warning? Is it A, tornado sighted by spotters? Is it B, radar indication of a tornadic rotation? Is it C, spotter indicates tornado formation looks imminent? Or D, all of the above? Who says A? Who says B? C? Or D? Okay, most of you think D, and yes, D is the correct answer. Any one of those scenarios are something that may cause us to issue a tornado warning. Okay, now if we're issuing the warnings, you got to have a way to receive them. And now more than ever before, it is so easy to get warning information through a variety of means, many of them on your smartphone, right? There's a ton of different types of apps. And if you're a spotter, these are all good types of apps to have on your phone. Radar apps, there's hundreds, literally hundreds of radar apps out there. I've got my favorite that I use. I'll tell you what it is afterwards if you want to know. Many of you probably already use it. You can get mobile forecasts. This is a new widget that the National Weather Service has that you can put an icon on your phone, desktop, or whatever you want to call it, and you get your forecast for your area, or you can use your GPS to get the forecast there. You need a way to get the warnings. I think this may be the Red Cross app. Red Cross app is excellent for getting tornado warnings. And then finally, you're probably going to have social media on there. That's another good way to follow us. But you've also got to have an automated way to receive warning information from us. The new thing that we've been talking about over the last 2 or 3 years is wireless emergency alerts. Those are those things that show up on your phone. You don't remember signing up for them because you never did sign up for them. It's just a system that the FCC and the cell phone industry came up with to get our warnings directly from us to you. The only thing that your phones are going to go off for weather-wise in this part of the country are flash flood warnings and tornado warnings. If that goes off on your phone, it's probably a good idea to seek shelter because that storm is either very near you or will be moving near you in the very, very near future. And then finally, the old reliable. We've had these things for decades, weather radios. They're a great system to have if you want to be woken up for warnings anywhere in the county. They're also good at a business. It might sit on the shelf quiet most of the time until we issue the warning. It'll then go off and scare the bejeebies out of you and let you know that a warning's been issued. But again, it'll sit there quietly most of the time until we issue the warning, and that will alert you. It's exactly the kind of thing you need when you're not paying close attention to the weather. Okay, let's talk real quickly about weather safety when it comes to watches. If you've got any kind of outdoor plans going on and there's a watch in effect, these are all good things that you probably ought to consider. You need to touch base with your family and review the plan. One of the things I do when I'm at work, I'm usually at work when there's severe weather or when there's going to be severe weather. I just text everybody and say, hey, don't forget, if there's a warning issued, go down to this part of our basement, blah, blah, blah. I just run through it with them just to make sure we're all on the same page because I got kids, like a lot of you have kids, and sometimes kids are idiots and they don't do what they're supposed to do. And so I just tell them every time, you got to do this, okay? Are you in a mobile home? Well, if a watch is issued, especially if a tornado watch is issued, that's probably a good time to leave your mobile home and go stay with a buddy or go somewhere else where you've got more substantial shelter. If you stay in your mobile home and it's hit by a tornado, you are 10 times as likely to die as you would be if you were in a stick-built home. Okay, so do not be there don't wait for the warning to be issued to decide what you're going to do. Leave when the watch is issued. If you're going to be outdoors or got some other outdoor things going on, consider postponing or canceling outdoor events. One thing I think back to, this is like 5 years ago. My wife's a second grade teacher, and they had, they had park day, like one of those last days they're just trying to waste in May before school's out, right? And the kids were going to walk like a half mile to the city park in Pleasant Hill, and we had a tornado watch out. My wife's like, what do you suppose we should do? I'm like, what do you mean, what should you do? What kind of question is that? Yeah, so if you got something like that going on, or I don't care, whatever you got going on outside, maybe don't do it. Think about something else to do. Or if you are going to do it, make sure you've got a way to receive warnings and you can get to a shelter quickly. And obviously stay tuned for updated information. Now, I already mentioned this a little bit, but when a warning is issued, let's go through these one at a time. When it's a severe thunderstorm warning, maybe you're outside, your little Red Cross app tells you a severe thunderstorm warning is issued for your area. You don't have to do that much. Go inside, go into the interior of your house, stay away from windows. Pretty easy to do, right? When the tornado warning is issued, you want to get down, go inside, into the basement if you have one. If you don't have a basement, get to the lowest level possible. Get to an interior room, preferably one without windows, and also put as many walls between you and the tornado as possible. If you can get into a closet, great. If you can get into a bathroom, great. As long as you can put more walls between you and the tornado. I mentioned before that even if you don't have a basement and you've got a monster EF4 or EF5 bearing down on you, statistics show you are more than likely to survive if you go to an interior room on the lowest level. Okay? A lot of people lay in their bathtub, put some cushions over them or something like that. Okay? If you are driving, very simply, drive away from the tornado. Turn around, drive somewhere else. Now, we've all been on 435 at like 5 in the afternoon. Does traffic always flow smoothly? No, it doesn't, does it? Well, if you're on 435 and you see a tornado like a couple miles ahead and you're in gridlock, now what do? Oh, crap. I would say abandon your vehicle and run to a nearby building, whether it's a business or a house. If you've got to kick in the door to that house, kick it in. Seriously, you're going to be much better there than you are going to be trying to ride it out in your car. Okay, and also remember that thing I talked about earlier, situational awareness? The best plan is to not be there in the first place. Be aware of the weather, aware of what's coming in, and plan accordingly. Let's talk about after the storm hits. First of all, don't rush outside right away because A, it's still, maybe it quit raining, it quit hailing. You're like, woohoo, let's go out, let's see what happened. Well, you're still at risk of being struck by lightning. Lightning can strike up to 10 miles away from the parent thunderstorm. Additionally, maybe this was a devastating storm that moved through. Maybe there's trees down, power lines down. You may be walking along and not notice the power lines that you're about to step on. Get electrocuted. You don't need that. Okay, there's a variety of hazards that are going to be out there. Don't walk through floodwater. Floodwater is the nastiest stuff. It's got like oil in it, and it's a lot of times it's like raw sewage coming out of the sewer and stuff. It's gross, man. Do not walk through floodwaters at all if you can help it. Okay. Also, there may be weakened structures. Maybe your house or maybe your garage got hit and it's kind of rickety. You want to go in and just make sure everything's okay. Maybe not. Maybe just give it some time to make sure that structure isn't going to fall down. And finally, there could be gas leaks all over the place. If this is like a tornado and houses were ripped up, there could be explosions, there could be other stuff. You really got to be careful after the storms move through. Okay, first let's talk about mobile spotting. Now, Johnson County, the ECS folks that work with emergency management have a fantastic mobile spotting system. You guys have like a grid or something and you send people out to their predefined places. That's a good kind of mobile spotting because you actually have somebody on the other end that's really looking out for you, making sure they know that you're safe and they're steering you clear of the thunderstorms. For the rest of you, I would discourage going out, driving around looking for thunderstorms. The kind of spotting you're going to do is the stuff you're going to do from your home. You're going to let us know of the hail, you're going to let us know about wind damage, things like that. I would not encourage you, if you're not part of a formal spotting group like the Johnson County ECS, to go out and drive around looking for this stuff. I'm not training you to be a storm chaser. I want you to be a storm spotter and somebody that lives to do it another day. Okay? Now, if you are a mobile spotter, you've got to plan accordingly. Is your cell phone always going to work? Is the GPS system always going to work? No, not necessarily. You might be thinking, well, I got maps on here. I don't need any other road maps or anything. Well, maybe not. You lose data on your cell phone and now it's just a brick, right? It doesn't do anything for you. Maybe bring one of these road atlases along with you. Those DeLorme, what are they called? Atlas and Gazetteers that have like every single road in the state. Those things are fantastic. They're great to have as a backup. How are you going to communicate with anybody if you lose your cell phone? Well, the ECS folks are going to have your ham radio, right? You don't need no stinking cell phone. You got your ham radio, right? So you've got that. Maybe you're out of radio range. You got to be careful about that. What's the range? Are you on 2 meter? How far is your radio going to reach? You've got to plan to make sure that you've got alternate ways to stay in touch with the rest of the world so you can stay safe. And above all, you don't want to lose your situational awareness. Okay? All right, just kind of finishing up here we're towards the end here. For the mobile spotters in the room, you got to keep your situational awareness high. Make sure you know what's going on with the storms around you. That's where the radar app comes in handy, assuming you have data. You want to make sure you have good communications like we talked about, phone, radio, maybe some other texting people, something like that. You got to have your escape routes. We didn't talk about that, but I talked about the maps and I talked about having your backup maps. Make sure you can get out of where you're at. Don't go spotting or be parked on a dead-end road because your only way out of there may become blocked by a tornado that's advancing towards you. Don't go down a dirt road that's going to become impassable when you get an inch of rain. Make sure you got a minimum of 2 ways to get out of there. Okay? And always be evaluating whether or not those are still viable options. And then finally, make sure you have a safety zone. If that tornado is bearing down on you, be looking around to see, or maybe for those of you, Brian, I don't see anybody else in here I can ask right away. The folks, when they're deployed out, do they know where they're going? Like, do they always go to like B4?
Yeah, they always get an assigned a location. Yeah.
So they could go out on a quiet weather day and kind of scout it out saying, oh, hey, I've got this business a quarter mile down the road, or I've got something else that they should probably evaluate ahead of time before they need to go spotting.
I highly encourage that.
Yeah, okay, there you go. They should be looking for their shelter or their safe zone in advance. Okay. All right, real quick question here. What should you do if a tornado warning is issued when you're in a big box store? So you're in Target or Walmart and a tornado, or Home Depot or Lowe's and a tornado warning is issued. Should you A, leave it immediately, B, move to the designated shelter or the interior of the store, or C, move to the edge of the building? Who says A? Paranoid, aren't you, Brian? Who says B? Who says C? Yeah, the correct answer, the correct answer, or at least the answer we want, is B. Now, you might leave the store, Brian, and it turns out just fine, but we generally don't want you to leave, because what if you leave and you drive right into the tornado? Okay. We don't want you to go to the edge of the store, because the way these things are generally built, it's called tilt-up slab construction. They have these big cement walls that they just tilt up with a crane and they fasten them all together. And it's the roof structure that usually holds everything together. And as soon as the roof gets lifted off, oftentimes the walls collapse inward, outward. You just don't know which way they're going to collapse. That's what killed so many people, I think, in the Home Depot in Joplin, was the collapsing walls. The roof was compromised and the thing just fell down like a house of cards. They're really not sturdy structures. Again, remember your situational awareness. Maybe there's a tornado watch. Maybe now isn't the best time to go to the Nebraska Furniture Mart and look for a new TV. I mean, seriously, you have to be thinking about that and planning your life accordingly. Okay, finally, we're wrapping things up here. I want to talk about how to report. Again, if you did not pick up one of these little cards on the way in, I think they're probably still out there. The table is probably still up. Please pick one up on your way out, because it's got our 1-800 number on there. It's got how you can report via Twitter, Facebook, and an app called MPing, as well as some other guidance. But a little acronym to help you when you're talking about reporting to us, we want you to tell us. TEL stands for time, event, location. When did this occur? It occurred 5 minutes ago. What was the event? I had golf ball size hail that was covering the ground. And where did it occur? It occurred 3 miles south of, what are we in, the B&B movie theater here? 3 miles south of the B&B movie theater on, is that 169 or 69? 69. On 69, okay? And we'll go through each of those hazards real quick just to kind of talk about some of the idiosyncrasies of reporting this stuff. When it comes to hail, obviously what time did it fall? Okay? We want you to compare the size of the hail to a sports ball or a coin. And please do not report marble size hail. Also, I want to know about the biggest hailstone you have out there. Lets us know what the intensity of that thunderstorm is, or what that storm is capable of. Again, you might have 2 feet of pea-size hail and a golf ball size hailstone sitting on top of it, and I want to know about that golf ball size hailstone. Okay, I've got to know what the biggest hailstone is. And then finally, the location that occurred. How about with straight line winds? Well, we want you to talk about the damage. What is damage? Be as descriptive as possible. Now, I don't want to make light of the situation, but we get a lot of calls at like 10 o'clock at night when it's dark out, and people say, my house just got destroyed by a tornado. And we're like, destroyed? Yeah, destroyed. And so we're like, okay, we put that in the warning. And I go out there, drive out there the next day 80 miles to go look at it. And I'm looking around and said, where's that house that got destroyed? And they said, well, it's right there, don't you see it? And like had a window broken, a couple of shingles missing. Try to really make sure you know what you're talking about, okay? If you have a tree limb that's broken, describe how big around the branch is. Let us know if that was a healthy tree or was it a dead tree. If it's early in the spring, are the leaves out yet? Because that'll make a difference as to how strong the wind has to be. And finally, and most importantly, do not speculate as to the cause of the damage. Just because the neighborhood looks like a war zone doesn't mean you had a tornado come through necessarily. If you say we had a tornado, we might think you had a tornado when really you just had straight line winds coming through. Okay, so I need to know that. You might say, Andy, but the trees were twisted and the light posts were twisted. I know I had a tornado. Tornadoes don't twist things. Okay, that's a myth. The reason things twist in the wind is because they're not 100% symmetrical with exactly the same strength of wind hitting one side of it as another. Okay, there's unequal forces, and straight line winds can cause things to twist just like a tornado can. Okay, so keep that in mind. We talked about this quite a bit, but remember when we were talking about tornadoes and funnel clouds? Does it make sense? Should this be a tornado day? Doesn't mean you're not going to have tornadoes, but that should be a mental check. Is this rotating? Am I seeing the rotation? If I'm not seeing the rotation, am I seeing debris being kicked up by this thing at the bottom of the tornado? Okay, those are good questions to ask yourself. And then when you're doing it, what time is it? You got a tornado or a funnel cloud? Now, the most important thing I want you to pay attention to is the location. Oftentimes people will say, I got a tornado at the B&B Theater. Well, they're at the B&B Theater, but they're actually watching a tornado 3 miles west of the B&B Theater. So don't tell us just that you've got a tornado at the B&B Theater. Let us know, I'm at the B&B Theater and I see a tornado. It appears to be about 3 miles to my west. Okay, it can get very confusing in our office if we have 4 different people reporting the same tornado in 4 different locations. It happens a lot, and sometimes there are situations we're not sure if we have different tornadoes, a multiple tornado thunderstorm, or if it's just people looking at it from different directions and they're not quite reporting it right. With flooding, we want to know about roads closed due to flooding. We want to know about water over the roads. If you can estimate the depth, that would be great. Maybe you don't have flooding yet, but you have a rain gauge. We'd like to know about how much rain you received and how long it took to fall. Also, there is a form out there. I'm not going to hold it up. There is a sheet. If you want to be in our database at the National Weather Service so that we can call you or email you asking about severe storm reports, fill out that sheet and leave it with me before you leave for tonight. Even if you filled one out last year, fill one out again this year, because we're starting a new system that every 4 years, if somebody hasn't had a new sheet filled out every 4 years, we're going to remove them from the database because they haven't been back to training. Okay, so keep that in mind. Love to have you fill out that form and be part of our database. Okay, real quickly, survey question. What would you report? A, quarter hail. B, quarter-sized hail. C, marble-sized hail. D, big hail. Who says A? B, C, D. Okay, I see you up there in the balcony. B, quarter-size hail. Okay, another one. What would you report? 80-mile-an-hour wind, tornado damage, tree damage, 4 to 6 diameter healthy tree snapped. Who says A? Who says B? Who says C? Who says D? Yep. Now, some of you just waiting to see when everybody else raises their hand? You are? Okay, well, at least you're honest. Yeah, D. Okay, so just to wrap this up, I guess the last thing I want to leave with you, don't assume we know what's occurring or that somebody else is going to report that. I'd rather have 10 reports of the same tornado than everybody assuming we already know about it. There are so many times people tell us, they'll come up and show me a picture or something. I say, well, did you call it in? Well, no, I figured you knew about it. No, we don't know about it. That's why I'm coming out training you guys. You've got to call it in. And also, remember when I said we're staffed 24/7? Call us any time of the day or night. I don't care. That 1-800 number that's on the card will always be answered by somebody 24 hours a day. Never goes to voicemail. Okay? All right, real quick, one of the last things we're going to do, I want you to take out your phone and I want you to program in this 800 number. We're going to have a countdown clock with 30 seconds to do that. That's our spotter hotline. If you program that in now, call it National Weather Service or something like that, it'll be there for you when you need it. Okay, now there are several different ways to report severe weather. On the card that you're going to pick up on the way out, if you haven't already got it, we talk about Twitter, Facebook, the 1-800 number. There's an app called MPing. And on that form, on that little card, we tell you, though, that depending on what you're reporting, it should determine what you use to report things to us, okay? And I want to make an important distinction here. That's really, I just put that on today. That's an ugly color, isn't it? If you are reporting tornadoes or funnel clouds or hail, straight line winds, or flooding that could kill people, we want you to phone us and call us with that report because we may have questions. We want to make sure we get the information as accurately as possible. If you just got run-of-the-mill hail or run-of-the-mill kind of low-end wind damage or something like that, tweet it to us, Facebook us, whatever. But still, even if you do have those and you call it in, follow it up with a photo. Tweet us a photo. Say, hey, I just spoke with you guys. Here's the photo of it. We'd love that. Okay, that photo helps so much. But again, if it is something important like this, we'd much prefer you call us. All right, last thing we're going to talk about. I mentioned that we had El Nino. We're just coming out of a very, very strong El Nino, one of the strongest ones in the last 50 years, I believe. And we're transitioning to something called El Nino neutral conditions. Well, we've looked back through the past El Nino going to non-El Nino summers, and essentially what it told us is we have a slightly lower chance of tornadoes and what was the other thing? Of slightly lower chance of hail, severe hail, and a slightly lower chance of tornadoes in our area. The blue colors, the darker the blue, the lower the stronger the signal that there's less of a chance of that occurring. However, what I want to say is, if we only had one tornado this spring, but it was an F4 that went right through the heart of Kansas City for 20 miles, would you think it was a bad tornado year? Yeah. Those kinds of things can happen. Even though we say there maybe will be fewer tornadoes this year, it only takes one or two to make it the worst year ever. Okay, so keep that in mind. Doesn't mean we're not going to need you. It just means that if we're lucky, maybe it won't be all that bad. We'll see. Last year we had about 20 tornadoes in our forecast area, so we're hoping for a little bit lower amount this year. That is all I have. I really appreciate you guys coming out and your patience sitting through this thing. If you have any questions, I'll take them now. Otherwise, we'll turn you loose. You want to turn the lights up in here? Okay, I don't see any hands, so thanks a lot for coming out. Have a good night.